Good evening everyone. Today we are going to discuss the daily Leetcode challenge of 11 January 2023. That is question number 1443. Minimum time to collect all apples in a tree. So see what the question is saying. Question is saying we are given an undirected tree. There are two types of trees. One is directed and other is undirected. In directed tree you can only move from one edge to another, and in undirected tree there is bidirectional movement possible. Okay. So let's read the question. It is saying given an undirected tree which is having n number of vertices from 0 to n minus 1, and it has some apples in the vertices, and we spend 1 second to walk over one edge over the tree. We have to return the minimum time in seconds which we have to spend to collect all the apples in the tree, and we have to start from vertex 0 and coming back to this vertex. Okay. So the edges of the undirected tree, okay, the question is saying that this is an undirected tree and there are some apples available, and you have to start from the zero vertex, and you will have to collect all the apples and then come back to the zero vertex. Okay, so this is the question asking you. So I ask you to please try it once on your own, then move on with the video. So now I hope you have tried the question. Now move on to the question. The question is saying that you are given n vertices, the edges are given to you, and there is a boolean array which has apple. This boolean array told you whether the following vertices have the apple or not. Okay, so here 4, 5, 2 which are marked in red are having apple. Okay, so what will be the intuitive approach to solve this question? See, what we can say, if we have to find the all the apples, we have to check till the last node or last vertices. Yes or no? We have to go to the last node to check whether it has an apple or not. So there are two type of traversals we know. One is breadth first search and other is depth first search. So can you tell which search should be used here? Yes, you are right. Depth first search should be used here because we can reach the depth and then we can come back. Okay. So what you actually have to do here, let me show you by this example. In this example, what we exactly have to find is we move from 0 to 1. It is 1 unit of time. Then we move from 1 to 4. It is 1 unit of time. Okay. So it is having an apple. Okay. Same, we move from 1 to 5. It is having 1 unit of time. And for this case, it is also having 1 unit of time. So total is 4. And 4 into 2 is equal to 8. Why multiplied by 2? Because it is just the time to go there. It should be multiplied by 2 because you also have to come back to the original vertex. Yes or no? So now what we can say, we have to, so the question is very simple. You just have to apply the depth first search and check whether the vertices has apple or not, and you have to return that. Are you getting the approach? Let me show you this example as well. First we are at the original node. Okay, here, and we move to this node 1, and then next doesn't have apple, so we return 0 from here, 0 from here. When we move here, we check whether its children have apple or not. So its children have apple, so we return 1. Its children does not have apple, so we return 0. So this is what is happening here. Okay. So now what actually you have to do is you just simply have to go to the original initial node. Then you have to move to the next node and check whether it has apple or not. If it has apple, you will say yes. If it doesn't have apple, you will say no. Okay, that means if it has apple, then it will return 1. If it does not have apple, you will check for its children whether they are having apple or not. If they are having apple, they will return 1 and it will return 1. Okay, so this is the overall approach. You have to check whether the node has apple or its children have apple, and you have to return accordingly, and you multiply the DFS answer by twice so you can get the total time of travel. Okay, because DFS will give you the time to reach the end or reach the apple, but for returning time you have to multiply it by 2. So that is our overall approach. So now let us move to the coding part. Okay, now for the coding part you need to create a adjacency list. So what is an adjacency list, you ask? For that you need to study about graphs. Okay, so what actually adjacency list is, let me show you. Like if 0 is the vertex, it is connected to what? 1 and 2. So it is an adjacency list. Then for 1 it is connected to 0, 4 and 5. So that is how you make a adjacency list. For 4, if I have to write 4, adjacency list is 1 only. For 5, it has also 1 only. For 2, if you write, it will have 0, 3 and 6. So adjacency list stores all the adjacents. So we do not repeat the adjacent. That's why adjacency list is created in such questions. So how do you create an adjacency list? You just make a vector of vector, okay? And as simple as this, you will create an adjacency list. You have to provide the size and let the size be n because it has n number of vertices. So now what you have to do? We have to apply DFS, right? So for DFS, first you also have to provide a value to this adjacency list, yes or no? So for that you will do for auto vertices to adjacency list. You will push back, like let me tell you, adjacency list. So similar, it is showing relation of 0 to 1, first node to second, and similarly you will make a relation from second node to first, like this. So what it is doing, it is creating a relation of 0 to 1 and 1 to 0. That means 0 have a relation with 1, and for 1 it is also having a relation with 0. See, 0 relation with 1 and 1 relation with 0. This is what adjacency list is doing by this step. So now what you have to do, what I told you, you have to apply a DFS, yes or no? So let us just write return DFS. What will you pass in this? You will pass the current node, the distance from root node, the parent node, because from above 0 node are not having any node, so you write it as -1. You will also pass the has apples boolean array because you will have to check for the apples, and adjacency list you will also pass to store the data in adjacency list. Okay, so now let us write the DFS function. So what will be the DFS function data type here? It will be int, because we have to return an integer value, exactly, right? And so what will be the DFS function? It will be int DFS. You are passing the node int distance of the node, current node from 0th node. So let me write it as current node if you want. No, node is fine. Current node will be lengthier to write. Int distance is the distance, and you will write the int parent. Parent is, it will be checking for parent node, okay? And now you will write, let us just copy this because you have to pass. And how will you pass an adjacency list? You will pass it by reference. For by reference pass, you will use this AND operator. Okay. So by reference passing means whatever value is adjusted here, it will be throughout the function. Okay. That is why by reference is used. Okay. So now, what will be the first thing you will write? You will write a distance of children. That is right. Let us write it as distance children. And you will write as a distance from root. Let us write as distant root. Let it be 0 initially. So now for DFS, what you do? You will apply a traversal. From where? From initial node to the adjacency list current node, whichever the current node is. Okay, and inside that, what will we check? You will check if this node is equal to its parent node. If that will be the case, we will not go with the traversal. But if it is not the case, we will go with the traversal. So we will write if v does not equal to parent, we go to the DFS. Inside the DFS, what we are doing? We are storing the distance of children. Distance of children or distance of root? Can you tell? It is distance of root, because we are checking the distance from root. So it will be distance of root from distance of the node from root is distance root. That is what I mean to say. Okay. So now what you can write, distance from root is equal to, we will apply the DFS function. So what will be the current node be? Current node will become the v, and its distance will become +1 because we are moving 1 second. Yes or no? Distance +1. What will be the parent node? Parent node will be the current node. So parent node will become the current node. Okay, and has apple function will remain same, and adjacency list will also remain same. Now, if this is done, you will get a distance from the root. Okay, now what we have to do, if the distance of root exists, that there is a distance for the children node or the node which has apple, and it is not equal to 0. What we will write? We will write the distance of children from here, and that will be equal to distance of root minus distance. What it exactly means is, suppose we have to find the distance from 1 to 5. Yes or no? This is the distance from parent to children. So for getting that distance, what you will have to do, you will have to find the distance from 1 to 5, that is the distance from root node, and you will subtract the distance from 1 to 0, that is the current distance. Yes or no? So if you do that, you are getting the distance of children. So that is what we have written here. We are getting the distance of children by this. So once when this loop is over, you will exit the loop, and what will you get? That is, if, what are you getting? If the distance of children exists, or, so there are only two cases. Either the children have apple or the node have apple. If the children have apple, the distance of children will exist. And but in this case, the children doesn't have apple, but the node itself has apple. So we will check if whether has apple boolean array have a value true at that node. If it is true, then we can return what? We can return distance of children plus distance. And the distance will keep on adding, na? Because 4 will return 1, 1 will return 1, then 5 will also return 1, so 3, and from here you will get 1, so 4, 4 into 2, 8. In the second case, 5 will return 1, then 1 will return 1, total 2, and this 2 will return 1, total 3, and 3 into 2, that is 6. So, and that is your output. So here, what you will get after this, and if this is not the case, you can simply return 0. That means the tree ended, you can say, okay? So that is what is happening here. Let us just run this and check if it has any issues. Runtime error. Let me just check where it is happening. Okay, so here we have written adjacent date, but we have to insert the edges now. These adjacency, these vertices, nodes we have to insert into the adjacency list. So we iterate through the edges. So it should be edges. Now it should work. Let me check. It is giving wrong answer. Okay, what is happening? Okay, also we didn't multiply it by 2 because that will be our answer, na? Okay, my bad. And if we multiply it by 2, we will get the correct answer. Yes, finally we are getting correct answer. Lot of silly mistakes. So please avoid these kind of silly mistakes and code properly. But these kind of mistakes are also necessary because it helps you to debug your code and learn more. And these are very minor mistakes, but you will face them in your coding journey. So don't be afraid of them and deal with them. Let us just submit this and I will brief you the whole theory again. So yeah, it is getting submitted. So now what, let me just tell you what actually happened. So this is a very basic question. You just have to do a BFS and check whether that node has an apple or not. You are multiplied by 2 because you have also have to return to the initial node. So the path distance or length become double, path time become double. Okay, that's why you multiplied by 2. What we actually do, we created an adjacency list, we inserted the edges inside that, and then we applied a DFS. Inside the DFS, we checked whether the current node is equal to parent. If it is not equal, then we can apply the DFS. Otherwise, we cannot apply it. And when we applied the DFS, we checked if the distance from root node exists, that there are root node exist or not, that there is some distance from root node and apple node, then what we have to do? We have to find the distance of children from its parent node. That's what we have done. And after all this process, we are returning the total distance. That's why you are summing it. And this total function will return an integer value to the main function and it is multiplied by 2 and we are getting our answer. So this is all you have to do. You all have to just apply DFS and think upon traversal. Most of the tree graph questions are done by DFS and BFS, so you must learn these concepts and learn about adjacency list. These are tools to make your coding easier, to make questions easier. Okay, so the time complexity for this code will be ON, that is linear time complexity, and the space complexity will also be a linear space complexity. If you have any other doubt, please let me know in the comment section. You can also write other questions you want me to solve for you. Please like, share and subscribe and comment down your thoughts. It helps me to understand what exactly you are looking for in a solution. Okay, so thank you for watching. Bye bye.